Hello everyone, my name is Harika, working as Assistant Professor in the Department of Computer Science and Engineering at Marri Laxman Reddy Institute of Technology and Management. In this session, I am going to explain about deadlocks. In this, some subtopics are deadlock problem, system model, deadlock characterization, methods for handling deadlocks, deadlock prevention, deadlock avoidance, and detection and recovery from the deadlock. These are the topics, subtopics in the deadlocks. Actually, what is deadlock? A set of blocked processes. A set of blocked processes, each holding a resource and waiting to acquire a resource held by some other process. That means, for example, P1, P2 are two processes, R1 and R2 are resources. Here process 1 is holding the resource type R1 and it is process 1 is requesting the resource type R2. So here it is requesting. Okay, and at the same time process P2 is holding the resource type R2 and it is also requesting for resource type R1. Whenever process P1 holds R1 and it is waiting for R2. So it is requesting R2 until and unless the resource R2 is hold by process P1, the process P1 is not executed because P1 needs R1 and R2, both resources required for the execution. So until R2 receives, it will wait for R2. At the same time, process P2 also holding R2 and it is requesting for R1. Until and unless R1 is acquired for P2, then it is executed. Means if R1, R2 are available for process P2, then it is executed. Otherwise, it will still in waiting condition. So here P1 is in waiting condition for R2 and P2 is in waiting condition for R1. So no process means P1 or P2 are not executed. So this means deadlocks. This is nothing but deadlock. For example, we are taking as bridge crossing example. Here, this is a vehicle A and B and so on. So here, traffic only in one direction. This is okay. Here in this bridge, traffic is in only one direction. So that means each section of a bridge can be viewed as a resource. And here vehicle, for example A and B, these two are the vehicles need to cross the bridge, but A wants to cross first but B is there, so A cannot cross, and also at the same time B wants to cross first, then B also cannot cross the bridge because A is there. If that means it is a deadlock. So if the deadlock occurs, it can be resolved only one of the car backs up. Here one more car is there. See, like that. One of the car means in this A and B, one of the car should backs up. That means preempt resources and roll back. If B car go back, then A will go forward. Otherwise, if A car go backside, then B will go. Means like in this way. Okay. But if there are several cars are there, C and so on. So several cars may have to backed up if the deadlock occurs. In this case, starvation is possible. And next one is system model. In the system model, mainly we have resources like R1, R2, R3 and so on, Rm. These are the resource types. Resource is represented in the form of square. In that we have dots or okay. In that we four instances here. Four instances. This is R1. This is resource type R1 and which is having four instances inside. For example, instances means here resource type means whether it is a CPU cycle, memory space or IO devices. For example, if you take IO device as R1, I mean resource, in that again you need to take some instance like printer. So there are four printers must be used for the purpose of different process execution in the CPU. So each resource type Ri has Wi instance. So these are the instances. Okay. And each process utilizes a resource as follows. Request. Here process P1 for example is requesting R1. Resource type R1. So if it is the request is granted, then request is granted immediately, then the resource is available for the purpose of process P1 execution. Then it is if it is granted, then it will be used by use means the process P1 is used by use means process P1 is using the resource type R1. So in this case, if the R1 is having instances, four instances, in one of those instance, the P1 process P1 will be used. After using, release means after using the instance of that particular resource type, that will be released. Okay. For example, here two processes, one printer and one DVD drive, and two processes and two hard disks. These are the resources available for the purpose of execution of process. Next, deadlock characterization. Here, when the deadlock can arise, means some of the conditions. Here, four conditions are there. If these four conditions are held simultaneously, then deadlock can arise. What are those conditions? Mutual exclusion, hold and wait, no preemption, and circular wait. These are the four conditions. What is mutual exclusion? Here, P1. Okay. Let us take one process only. Mutual exclusion. Okay, let me take two processes for clear understanding. Mutual exclusion means only one process at a time can use a resource. See here, process 1 holds R1 resource. It is acquiring the R1 resource and requesting for R2 resource. At the same time, P2 holds the resource R2 and requests for the resource R1. Okay. Here, until and unless P1 executes, the R1 resource R1 cannot be released by P1. So that means this resource is not shareable. It is not shared for any other processes. Here, other process means P2. At the same time, R2 also. R2 is held by P2, means process P2. So, until and unless P2 execution completes, the R2 may not release. So, that means it will not shareable to any other process. That is nothing but mutual exclusion. In that case, deadlock may occur. And next, hold and wait. Hold and wait. Okay. Let me write again. So, hold and wait. A process holding at least one resource and is waiting to acquire additional resource held by some other process. So here P1, process P1 is holding R1 resource and process P1 is requesting R2 resource. Same, P2 is holding R2 request, R2 resource, and P2 is requesting for R1. Okay. So here P1, process P1 is holding resource R1 and it is waiting for resource R2. Right. So until and unless resource R2 is available for the purpose of execution of P1, it cannot release R1. The process P1 cannot release R1 until it completes its execution. So until its execution, this is holds this resource, resource 1, and it is waiting for resource 2. Same P2 also. In this case also, deadlock may occur. And next condition is what? No preemption. No preemption means not preemptive. Not preemptive. Non-preemption means if the process, as we know, P1, P2 and so on. Okay, let us, we are taking from the Reddy queue, P1, P2 are entered into the CPU for the purpose of execution. For this, here R1 and wait a minute, R1 and R2 are used for P1. Okay, so once P1 is entered into the CPU, after completion of its execution only, then it will exit from the CPU. Until and unless it will not exit from the CPU. So for the purpose of execution of process P1, it must use resource 1 and resource 2 in this example. So until R1 and R2 resources available for P1, it will wait, and after completion of its once CPU is released, once other process is released and CPU is giving these resources for the purpose of process P1 execution, after that it will completes its execution, then from the CPU it will exit, then only it will release these resources those released resources will be available for the execution of next process. So here that is nothing but no preemption, non-preemptive. Okay. And next, circular wait. Circular wait means here there exists set of a set P0, P1 and so on Pn. So n number of processes will be there in the CPU to execute. Okay. In this case, P0 is waiting for the resource that is held by P1. And also P1 is waiting for a resource that is held by P2. And so on. At last, Pn is waiting for the resource that is held by P0. So this is nothing but circular wait. So here, in this case, we have taken P1, P2 are two processes as an example. So P1 is waiting for the resource R2. That is this R2 that is held by process P2. And again, P2 is waiting for the process R1 which is held by P1. In this case also, deadlock occurs. In these four conditions, deadlock can arise. So, whereas resource allocation graph that is represented by G of V comma E. So G means resource allocation graph and V comma E means V means vertices. Vertices. E means edges. So in this, vertices are of two types. Two types means process and resources. Process and resources. And edges are request edge and assignment edge. So here request edge and assignment edge. Vertices are of partition in two types, process and resource, and edges are partitioned into two types, request and assignment edges. So here process will be represented in circle and resource is represented in the form of square, whether it is having single instance or multiple instances. Okay, this is process represented as circle and this is resource type with the instance multiple instances. Here we have taken 4 instances and P1, for example, process P1 and here R1. This is the with 4 instances. This is R1. Okay. So here P1 is requesting the resource type instance, any instance or multiple instance based on the requirement of that particular process. So here it is requesting. This directed edge is requesting. Process P1 is requesting the instance of resource type R1, whereas here P1, we are taking one example only. This is R1 and if the directed edge is like this, this is assignment edge. Nothing but the instance of R1 is assigned to process P1. Means holding. Already it is assigned to that particular process. Those are nothing but request edge and assignment edge. Okay, here just now I explained process is represented as circle and resource type with 4 instances. See, this is the resource and with 4 instances. And PI requests instance of RJ. Here process is requesting the instance of resource type RJ. So one of the instance can be process P1. PI is requesting one of the instance of that particular resource type RJ. PI is holding an instance of RJ. So one of the instance or multiple instances of resource type RJ is held if the one instance of resource type RJ is held by the process PI. For example, we have this example for the resource allocation graph. For example, we have taken P1, P2, P3 are of three processes. P1, P2, P3 are the three processes, and R1, R2, R3, R4 are the three resource types with some instances. Okay, so here in this case P3 is executes first. Means P3 is holding the instance of resource type R3, and P2 is requesting an instance of resource type R3, and also it is holding the resource type instance of resource type R1 and R2. Here one instance is held by P2. Okay, whereas P1 it is requesting the instance of resource type R1, and also P1 is holding the instance of resource type R2. Okay, here is the R4 resource type with 3 instances. Those are not using for this processes. If there is any requirement, then the process will be used those resources or instances, otherwise no. Okay, first P3 will execute first. P3 is holding instance of R3, right? So after completes its execution, it will be released instance of R3. It will be released the instance of R3. Then it is available for P2. So now P2 is holding instance of resource type R1 and also R2. Again it is requested for instance of R3, right? So that will be released. Then it is assigned to P2, process P2. By using these R1, R2, R3 resource type with that instances, the P2 will be executed. Fine. Then after completion of its execution, it will be released R1 resource type instance, and another instance is the type R2. These two are released by P2. Then those are available for the execution of P1. So instance of resource type R1 is available for P1 for the execution. So then it will be executed by using R1, R2 instances, resource types of that particular resources. Okay. So P1, P2, P3 are executed. This is example of resource allocation graph. Now, resource allocation graph with a deadlock. See here, this is the graph, and same graph I have taken as an example, but here one more edge is there, that is requesting Here P3 is requesting the instance of resource type R2. So P1, P2, P3 are the processes. R1, R2, R3 are for the resource types with some instances. Okay, here P3 needs to execute. If P3 needs to execute, it is holding P3 is holding the instance of resource type R3 and it is requesting for instance of resource type R2. Okay. At the same time, P2 is requesting the instance of resource type R3 and it is also holding the instance of resource type R2. So, if you observe here, the cycle is formed. P2 to R3, R3 to P3, P3 to R2, R2 to P2. If there is any cycle in this resource allocation graph, there may be chance of occurrence of deadlock. If there is no cycle, so there is no deadlock. Here cycle is formed. There may be chance of occurring deadlock. See here, until P3 is holding instance of R3 and requesting for the instance of R2. At the same time, P2 is holding instance of R2 and it is also requesting for instance of R3. So neither P1, neither P2 or nor P3 will be executed. So there is a deadlock, right? So if P2 is not executed, then R1 instance is not available for the purpose of P1 process execution. So there is a deadlock. And next, graph with a cycle but no deadlock. Here there is a cycle formed but there is no deadlock. How? We can see here. In this process 1, process P1, P2, P3, P4 are the processes we have taken as an example and R1, R2 are the resources with some instances. Okay, here first this P2 is not requesting for any other resource. So it is already, so this P2 holds resource type of R1 resource with some instance. So it is holding the instance of resource type R1 but it is not requesting for any other resource. It is sufficient with that particular resource. So by using this, it will be executed. Fine. After execution of this P2, the resource type, the instance of resource type R1 is released. Okay. Then here, look at here. P4 also not requesting for any other resource. It is holding the instance of resource type R2. So after completion of its execution, that will be released that instance of R2. So P2 is released and P4 is released the instance of resource type R1 and also R2. So now we're coming to P3. P3 holds the instance of resource type R1 and it is requesting for the instance of type, which type? R2, resource type R2. So it is here, by using this instance it can be executed and also it is requested for instance of R2. So it is whether there are two instances in the R2. Okay, it is one of the instance of resource type R2 is already held by process P1. So here P4 is released this instance R2 instance, right? So that will be used for process P3 execution. So P3 is having instance of R1 and also instance of R2. So by using these two, the process P3 will be executed. Then after, the process is releasing those two instances of R1 and R2 resources. Okay. So now for the purpose of execution of process P1, R1 resource type and R2 resource type with instances are available. So simply it is executing and release those resources to the CPU. So whether it is forming a cycle, see here, it is forming a cycle. P1 is requesting R1 hold by P3, P3 is requesting R2 hold by R2 is holding, who is holding? P1. So it is cycle is there, but there is no deadlock because multiple instances are there in the resource types R1 and R2. If there is single instance, it is not there. There is single instance, there might be chance of deadlock occurrence. If there are multiple instances, there is no deadlock with a cycle but no deadlock. This is an example, and remaining topics will be discussed in next session. Thank you.